In the previous lesson, we spoke about transformations, and we also used an animation to help visualize the transformations applied to y equals x squared. But unfortunately, there wasn't really much of an explanation, like why is there a vertical translation? Why does k control the vertical translation? Whether it's up or down, why does h create a horizontal translation, and so forth and so on. So in this lesson, we'll try to really explain what we saw on the animation. Okay, so let's go with k first. Okay, so it's a, h, and k. We're going to work with k first. Why does k cause a vertical translation? Whether it's up or down, we're going to see why that's the case. So we always start off with a parabola y equals x squared, our original. So it's going to be 4, 1, 0, 1, 4. It's a good idea to memorize these 5 numbers because we're going to see them quite often. And it's pretty easy to remember these numbers because not only are they perfect squares, but there's a pattern here and there's a symmetry. So pretty easy to remember these 5 numbers. Okay, so now I'm going to fill in this table for y equals x squared plus 4. Okay, so I have the table for y equals x squared, but y equals x squared plus 4. So give yourself some time, try to fill this in, but you will get 8, 5, 4, 5, 8. Interesting. Okay, so I really want you to take a look at these y values for the original y equals x squared parabola, and then take a look at the y values of y equals squared plus 4. You know what? Let's do one more. Y equals x squared minus 5. Wow, okay. So hopefully you see a pattern. To get the y coordinates of y equals x squared plus 4, what did you do? You took y equals x squared and you took these y values and you added by 4, right? And to get these y values, you took these y values and subtracted by 5. So really, you're just manipulating the original y coordinates to get the new y coordinates. You take the original y coordinates for the parabola y equals x squared, and then you either add or you subtract it. Well, think about it, okay? If you're increasing or decreasing the y coordinates to obtain the new points, what kind of transformation are you really creating here? Okay, hopefully you can really imagine, okay, if you're sliding all the points up and down because you're really just changing the y coordinates by either adding or subtracting, then it's gonna result in a vertical translation. It makes perfect sense that when we manipulate k, we create a vertical translation because you're changing the y coordinates by adding by k, or well, if k is negative, then I guess you're subtracting. But all you're doing is manipulating the original y coordinates by adding by k. And if k is negative, then your original y coordinates will decrease. Or sorry, your new y coordinates will be lesser than that of the original y coordinates, which means the points are now lower on the Cartesian plane. Okay, I made a typo here. Why does h cause not a vertical translation, a horizontal translation? Okay, so one thing we're going to start off with the original. So 41014, beautiful. I'm actually going to change x minus 6 to x minus 2. It's going to help us visualize this effect. So let's change it x minus 2. So this becomes 16. Negative 1 minus 2 is negative 3. 9, 4, 1, 0. Okay. So, you know what? Before we talk about this table, let's just find the y coordinates for both tables. Okay, negative 2 plus 4 is going to be negative 2, sorry, it's 2 squared is 4, 3 squared 9, 16, 25, 36. Okay, perfect. So let's think about it. x minus 2 all squared. Okay, let's say I really want to obtain the same y values beforehand. Okay, in order to obtain the exact same y values before, because I see in the brackets x minus 2, I can't sub in the same x value. Okay, it makes no sense. Like, for example, if I sub in 0 for y equals x squared, I get a y value of 0. If I really want a y value of 0, I can't let x equal 0. In fact, how do I get a y value of 0? Well, if I look at the table, I can get a y value of 0 if I let x equals 2. Wait a minute. For here, I let x equals 0 and I get 0. For here, I need to let x equals 2. In fact, if I want to get the exact same y value, I need to increase the value of x by 2. I need to increase the value of x by 2 because in the equation, I have a minus 2. To offset the effect of minus 2, I need to increase the value of x by 2 to obtain the same y value. So if you increase the y values by 2, you'll get the same y value. So for example, negative 1, the y value here is 1, but to get the same y value, I need to increase negative 1 by 2. See? Like if I have, and that's, of course, negative 1 added by 2 is 1. So 1, guess what? The y-coordinate is 1. It makes sense. If you look at the equation, you study the equation, if you increase the x values by 2, it will offset this subtraction by 2, and then you'll be able to get the same y-coordinate as before. Now here, it's x plus 4 all squared. If I want the same y-coordinate, to offset the effect of this plus 4 in the equation, I need to decrease the values of x by 4 to get the same y-coordinate. I need to decrease the values of x by 4 in order to obtain the same y values. Okay, so really you need to undo the effect of what you see. If you're adding by 4 here, like in the equation, you need to decrease the values of x by 4. So here, when I see this, I automatically see a shift 3 units to the right. I need to offset this minus 3, which means I need to increase the x values by 3 to reach the same y values. Now, if I see, I don't know, let's say x plus 6. If I see this, I know I'm shifting 6 units to the left. And I'm shifting 6 units to the left because I see a plus 6, which means I need to decrease the original x coordinates by 6 in order to obtain the same y values. Now, some students, they suggest, okay, if this throws you off, just ignore this, but I'm just going to add it just to help. I don't know if it's going to help or confuse, but I'm going to add it anyways. So some students really want x plus h all squared. They love a plus here. But here, if it's plus here, okay, and if this confuses you, please ignore this. If it's x plus h, then that means if h is positive, you're going left. And if h is negative, you're going right. Okay? If you love the right vertex form as x plus h all squared, go ahead. But now you have to understand that a positive h means you're shifting to the left, and a negative h means you're shifting to the right. So that was very counterintuitive because when we think about our Cartesian plane, positive means right and negative means left. So even though you might, at first glance, you might be, oh, I really want to change vertex form to x plus h all squared. It's actually a better idea to do x minus h all squared because a positive h means you shift to the right and a negative h means you shift to the left. And that's very intuitive because that's in line with your logic with the Cartesian plane and the xy axes. If that made no sense to you, just ignore that and just go back to the original logic of seeing negative 3 and understanding why you're going 3 to the right. It's because you're increasing the previous x values to 3 to obtain the same y coordinate. That's the logic that's the most important. Okay, we got some more transformations to go. Why does A cause reflection in the x-axis? Well, once again, original table. And then here, y equals minus, oh, interesting. it makes perfect sense to see a reflection in the x-axis because look at the y values. The signs all change. It go from positive to negative, but the magnitude, the size of the numbers are the same. So the distance to the x-axis is the same, but they're going in the opposite direction. So here you're going up and here you're going down. So if you do that to all the points, you'll see that it's a mirror image that you're creating using the x-axis. So it's a reflection in the x-axis. Okay, so now last one, stretch and compression. So we'll do 1, 0, 1, 4. So 6, so 24, 6, 0, 6, 24, 1/3, so it's going to be 4/3, 1/3, 0, 1/3, 4/3. All right. So this one, I think the animation did a really good job showing this, but like when I see y equals 6x squared, I know it's a vertical stretch by a factor of 6 because these values here are 6 times of that of before. These values here are 1/3 of what was before, okay, on the original y coordinates. So it makes sense if you're 6 times of that of before, now the distance from the point to the x-axis is 6 times of before. So it makes sense to say a vertical stretch here, and it makes sense here to say a vertical compression. It's all about that vertical distance from the point to the x-axis. So original y coordinate multiplied by a, when a is greater than 1, all the y coordinates from before will increase. So points will be further from the x-axis, described as a vertical stretch by a factor of, let's say, the magnitude of a, just in case a is negative. Okay, if a is negative, it has nothing to do with the stretch factor. When we talk about the stretch factor, we only care about the magnitude, the size of a. Okay, is the magnitude of a greater than 1 or is it between 0 and 1? Well, actually it says when a is greater than 1, so you know it's positive. I'm just gonna leave it like that though, because it's good notation when a is negative. Okay, so what about when a is between 0 and 1? So this is the one that, in fact, a lot of teachers can't agree and a lot of textbooks can't agree. So I'll try to convince why what I've written is correct. Vertical compression by a factor of 1 over a. I'll leave the absolute value bar. Okay. Let me clean that up. 1 over a. The magnitude of a. So I actually want to take the reciprocal of a. So for example, if a was 1/3 like we saw in the example above, then reciprocal 1/3 is 3. To me, that makes perfect sense because the way the textbook has it is vertical compression by a factor of a, or magnitude of a. Now this to me makes no sense, vertical compression by a factor of a, because now if someone says that, what they're really saying is the idea of stretch and compression is exactly the same. You're saying, if you are accepting this, you're basically saying stretch and compression is the same idea, but it's not the same idea. Stretch means that vertical distance is enlarging, and compression means the vertical distance is decreasing, okay, by some factor. So we cannot. This is I find it very weird the textbook would write this. Okay, that would basically say, one more time, stretch and compression mean the same thing. Okay, if you're saying this is correct, but clearly the words vertical stretch and vertical compression do not mean the same thing. So, for example, if let's go back to our example up here, if a is 1/3, you want to say vertical compression by a factor of 3, as opposed to vertical compression by a factor of 1 over 3. Because if you do vertical compression by a factor of 1 over 3, if you think about it, it's like a double negative. you're actually going to, if you say vertical compression by a factor of 1 over 3, it really seems like you're going to apply vertical stretch by a factor of 3. So anyways, I really hope you can take your time, think about it. Okay, if you want to say I take the y coordinates divided by 3, okay, I want just, it's more of a actually an English issue as opposed to a math issue. The most important thing, to be honest with you, is that we agree that the y coordinates are being divided by 3. Anyways, vertical compression by a factor of 3 versus vertical compression by a factor of 1 over 3. Okay? So, which one of these statements, okay, to be honest, it's purely in English. Read these two lines very carefully and ask yourself, which one of these says, I'm going to take my original y coordinates and divide by 3? So I'm going to say this one, all right? Because this is a double negative, okay? That just does not make sense. So I'm going to cross this out and cross this out. Okay? Anyways, so I really want, the big idea of this lesson is to understand transformations through your number sense, okay? You're really just manipulating numbers. You're manipulating the original x coordinates by adding or subtracting by a value, and you're manipulating the y coordinates by, yes, you can add or subtract the y coordinates to shift up or down, or you can multiply by some value, and if it's negative, you're applying a reflection. So really understand transformations through manipulation of the original coordinates, because that's how we're going to look at transformations in grade 11 and grade 12. Okay, so really combine these ideas with what we did with the animation, and you should be set.